Okay. A conical tank is filled with water to 1/5 of the height. If the tank is inverted, at what fraction of the height will the water rise? Okay, let's do a diagram. Okay, see the diagram. The one on the left is before inversion, so this is before. Before inversion, while this is after inversion. So let's call the heights. As you can see from the diagram, the height of the cone, let's call it h. Why this is h2, that's the height after. This, remember, they said it is filled with water, so this is the water. This is water. That same cone is inverted, you see. So the first diagram forms a frustum, the water forms a frustum of a cone, while the second one forms normal cone. So, but what we know here is that they will have the same volume. So V1 must be equal to V2. So for now, okay, let's just, this is H1. This is the height before inversion. That's the height of the water before inversion. We are looking for this. So before I'll solve this, I will do some analysis in the next page. So let's go back to this page. Okay. So let's call the radius of the tank. As you can see, I've added these auxiliary lines. We are forming we have right triangles. So we have, let the radius of the tank be R, and here will be R2. But the radius of this, let's call it R1. That's the top here. Why this is R2. So we have two similar triangles in each of the diagram. Yes. So we're going to use similar triangle theorem. That's right triangle similarity theorem. So for the first one, we see that R1 over R will be equal to H minus H1 over H. Yes. So if we make it the subject R1, the subject, because remember, we don't know the radius of this small circle that will be formed. Yes. So let's make it the subject of formula. We now have H minus H1 times R over H. That's equation 1. So why the second one? Here, you see that R2 over R will now be H2 over H. Yes, as you can see. Therefore, if we make R2 the subject of formula, I have H2R over H. Let's call it equation 2. So what will you do now? Remember, the volume of water in the diagram, say, because I'm trying to derive after we'll come back to this. The volume is the same. The volume is the same. The volume of water in both. So if here is V1, here is V2, both of them are the same, the same water. So, since we have that V1 is equal to V2, and V1 is a frustum of the cone, and the volume of a frustum is 1 over 3 pi, the radius of the big one, R square H. That's the volume of the big one minus the volume of the small one, which is R1 square H minus H1. Why the volume of this one is just normal cone, 1 over 3 pi R, that's R2 squared H2. So, and what is common? 1 over 3 pi is common. So if we cancel out, we now have r square h minus r1 square h minus h1 is equal to r square h h2. R square h2. But remember, we are not giving R1, R2. So let's substitute. That's why we made it the subject of formula in these two equations. So if we substitute, I have R squared H minus, this is now H minus H1 over H times R all squared. H minus H1 times H minus H1. Why this is H2R all squared. H2R all over H all squared H2. So I have R squared H minus, this is also R squared. Why this is now H minus H1 cubed over H squared, yes, is equal to R squared H2 cubed over H squared, yes. Cancel out R2. We can cancel out R squared. See, yeah, also we have H minus H1 cubed over H squared is equal to H cubed, H2 cubed over H squared. So to clear let's get another thing. Therefore, we can easily see that if you multiply by H squared, we have H cubed minus H1 all cubed will be equal to H2 cubed. So that is the formula connecting the heights. So that's what we are going to use to solve this question. Yes. From here, let's go back. We've seen that, therefore, we've seen that H2 cubed will now be H cubed minus H1 cubed. So H2 is now the cube root of H cubed minus H1 cubed. So in the question, they say the water is filled to 1/5 of the height. So H1, so we substitute this cube root. We now have H minus, H1 is now H over 5. Yes, they said 1/5. So that's it. So we'll solve. Whatever I will get is the answer. So I have cube root of this H cubed minus this 4 over 5. That's 4 over 5. That's 64 over 125 H cubed. And if you subtract, we now have cube root of, this is 61 over 125 H cubed. And since 125 is a perfect cube, so our answer will now be option B, yes. Therefore, H2 will now be the cube root of 61 over 5H. Since we are looking for fraction, what fraction? So H2 over H will now be cube root of 61 over 5. So that's option